Hello everyone, so let's look at another question regarding buffers. And in this question we're asked to calculate the mass of ammonium chloride that must be used to prepare a 500 milliliter of a buffer solution that is already 0.1 molar in aqueous ammonia. So ammonia is of course NH3. So the solution already contains NH3, and we want to know how much NH4 plus we must essentially add, right? So ammonium chloride will be a source of ammonium, and that creates a buffer because those two species are an acid-base conjugate pair. Ammonium is the base, the conjugate acid is the NH4. Some more information about the buffer is that the buffer is required to have a pH of 9.15, and we're given that Kb for the base, so for the ammonia, is 1.8 times 10 to the negative 5. Alright, so let's think about what we are given. So we're given the pH, we're given the concentration of the ammonia, and we're given the Kb for the base. So I think the easiest place to start, and of course, okay, so we want the mass. And the mass, the only thing that we can relate to the mass is the concentration of the acid. So, we can relate the concentration using that given volume because we know what volume of buffer we want to prepare. So from that we can get the number of mole of the salt that we want, and then we can determine the mass of the salt that we want. Alright, so let's go ahead and look at that. So the pH of a buffer is of course given by the Henderson-Hasselbalch equation. So pKa plus log of the conjugate base divided by the acid concentration. Alright, so we have the pH. The pKa will be the Ka of the minus log of the Ka of the acid. Now let's just remind ourselves what the acid in this case is it's the NH4 plus. So if we think of our equilibrium, that's NH3 aqueous plus water. That is in equilibrium with NH4 plus OH minus. Right, that's why the pH is above 7 because it's a basic equilibrium. And what we are given is we're given a Kb value, right? 1.8 times 10 to the negative 5. Now what we need is we need the Ka of ammonium. So we have the Kb of ammonia, but we need the Ka of ammonium to use this equation in the acidic form. So one of the things that we will need to do, or just need to make a note of, is we will need to calculate the Ka of ammonium, which is going to be equal to Kw divided by Kb of ammonia. Alright, so that's 1.0 times 10 to the negative 14. Alright, is Kw divided by 1.8 times 10 to the negative 5, as it's given there. So that's one of the things that we will need. So we're given the pH, then we have the pKa log, we have the concentration of the base, so we can solve for what the concentration of the acid will need. So let's go ahead and solve this equation systematically. So I'm first going to solve for log of concentration base, and our base, remember in this case, is NH3. Our acid is NH4 plus. Alright, you can also write NH4Cl if you want. I mean, it doesn't really matter for whatever you want to write, as long as it's acidic form. And that should be equal to the pH minus the pKa. Alright, and then if we want to get rid of the log, we need to take 10 to the power, so that means we're left with NH3 divided by NH4 plus, so that becomes 10 to the power pH minus pKa. Alright, and what do we want? We want the concentration of NH4, so let's solve for that. That means the concentration of NH4, so we can multiply each side with NH4 or and divide, so that means this is going to be equal to the concentration of NH3 divided by 10 to the power pH minus pKa. Alright, you can even take that a step further and you can put the 10 to the power at the top and make it pKa minus pH. So you can stop wherever you are comfortable with in this derivation. So wherever you want to start putting in numbers and start working with it, that's totally fine. I'm just a lazy person and I like first taking it as far as possible. Yes, because remember, if you're going to take something to the top, then it has to become negative that something. So that is what we are then left with. Alright, so that's the concentration of the ammonia. Ammonium. Sorry. So what is the concentration, or let's go and do this. So we can actually still write something more, NH3, and then it becomes 10. pKa is negative log of Ka, and that's minus the pH. Alright, so now we're in the position to plug in some numbers. So our concentration of our ammonia is 0.10, and this must be multiplied with 10 to the power, which is raised to the power negative log of Ka, and Ka is like we have calculated there, so that's 1.0 times 10 to the negative 14, and 1.8 times 10 to the negative 5, minus the pH, which is given as 9.15. Alright, and this is all, if you put it into your calculator, this will all be equal to 0.1274 and so on molar. Alright, so that gives us a concentration for the ammonium. So, and this is of course equal to the concentration of NH4Cl. Right. So from that we can get the number of mole of ammonium chloride that we require, because that will be equal to the concentration of ammonium chloride multiplied by the volume of our buffer. Hence, it's this 0.1274 molar multiplied by 0.500 liter, the 500 milliliter, and I get 0.0637 mole ammonium chloride that we require. And once we have the number of mole, we of course can get the mass. because the mass is just equal to the number of mole times the molar mass. So number of mole NH4Cl multiplied by the molar mass NH4Cl, which in this case, so remember you have to include the chlorine in this because we're interested in the mass of the salt. We want to know how much of the salt we need to add. So 53.491 gram per mole. Alright, so notice the concentration of the acid NH4 plus, right? That is what we calculated, right? You could have said here, if you wanted to never confuse yourself, you can say, I mean, that is the concentration of NH4Cl, right? Because it's 1 to 1. And then you need to remind yourself that the mass that you are looking for needs to include that of the Cl. Alright, so that's the important thing, because the salt that you have to put, solids don't exist as ion form, that they must include a counter ion. So you have to have the ammonium and the chlorine minus. So your molar mass when you're working to a solid has to include the chlorine, and I get a rounded value here of 3.4 gram of ammonium chloride. Alright, so that is that is it. So most important things, I mean the math might be a bit difficult here, but you could of course always have calculated this stepwise. So you could first, for example, calculate what is the pH minus the pKa. Remember, pKa is negative log, so you must calculate pKa, that's negative log, and then say pH minus whatever that pKa value is. And then you could have put in the concentration of the ammonium, solve, take log, calculate it. You could have done it stepwise as well. So you don't have to solve for the maths, but I think it's a bit easier if you just do it like that. Then it's just one calculation at the end. But however works for you, that's perfectly fine. Alright, so yeah, thank you for watching, and I'll see you in the next video.